Imagine this massive, bat-like shape, just silent against a moonlit sky, slipping past defenses no other aircraft could even hope to penetrate.
That's the B-2 Spirit. Absolutely iconic.
Exactly. Now, picture its successor, the B-21 Raider, poised to do something maybe even more groundbreaking. Today, we're doing a deep dive into that evolution, the technological and strategic journey from the B-2 Spirit to the, well, revolutionary B-21 Raider.
And our mission here, it isn't just comparing two amazing flying machines, right?
Right.
It's really about understanding a fundamental shift, a shift in military aviation and the whole nature of strategic deterrence.
Yeah.
We've pulled together a pretty detailed analysis comparing these two landmark aircraft to really show you why this matters.
And what you're about to discover, hopefully, is that the B-21 isn't just like a better B-2.
No, not at all.
It's a completely new class of strategic asset. It represents a whole fresh doctrine for air power in the 21st century.
That's the key.
So we're going to unpack the strategic, the economic, and the technological drivers that shaped them both. Help you understand not just what they are, but why they matter.
Okay.
So to really grasp the technology, I think we first need to understand the vastly different worlds these bombers were born into.
That's exactly right. And what's truly illuminating here is how directly the geopolitics, the landscape at the time, dictated the design philosophy for each one. The B-2 Spirit, conceived during the Cold War under the Advanced Technology Bomber Program, the ATB, it was, in essence, an exquisite solution for one singular threat.
The Soviet Union.
Precisely. Its genesis was crystal clear. Penetrate that dense Soviet air defense network, deliver nuclear payloads.
Right.
And that singular, really existential threat meant performance was absolutely paramount. Cost is no object was pretty much the guiding principle.
And that cost as no object approach, it really made the B-2 incredibly expensive, didn't it?
Oh, unbelievably so.
What were the real world consequences of that huge price tag?
Well, the program costs were just immense. Initial unit costs estimated around $737 million back in 1997 dollars.
Wow.
Then climbing to maybe $1.16 billion per aircraft in $98. And some analyses, if you factor in all the development, put the total cost over $2 billion per plane.
Per plane.
Per plane. So when the Soviet Union collapsed, the B-2 basically lost its main justification overnight.
Right.
And Congress reacted by slashing the planned buy from 132 bombers way down to just 21. So 20 operational, one test articles.
So that left a tiny fleet.
Exactly. A small, incredibly potent, but ultimately exquisite fleet, as you said.
Yeah.
And that numerical insufficiency meant it just wasn't really suited for high-tempo conventional conflicts.
Okay.
Each B-2 became this strategic asset of such high value that losing one would be, well, catastrophic.
Yeah, politically and militarily.
Absolutely.
Yeah.
Potentially inducing operational hesitancy.
Yeah.
Are we really going to risk this irreplaceable asset? It really demonstrated that a capability, no matter how advanced, it just can't be strategically scalable if it's economically unsustainable.
So the B-2 was this technological marvel, but its huge cost almost became its Achilles heel. That sounds like a really hard-learned lesson.
It was.
Did that fundamentally reshape how they approached the B-21's design?
It absolutely did. The B-21 Raider, it was conceived in response to a very different world, a multipolar world, facing peer and near-peer adversaries like China and Russia.
Right.
In these highly contested A2AD environments, anti-accessoria denial zones, places where adversaries have built sophisticated defenses to keep forces out.
Okay.
So the philosophy shifted radically. Affordability wasn't just a goal anymore. It was a mandatory requirement. A KPP, a key performance parameter.
Mandated from the top.
Yes. Former Secretary of Defense Robert Gates made the average procurement unit cost, the APUC, a KPP.
And what was the target?
The target ATDC was $550 million in 2010 dollars. That's about $692 million in 2022 money.
Still a lot, but compared to the B-2.
A fraction of the B-2's cost, exactly. And this focus on affordability allows for a much larger fleet, at least 100 aircraft.
A five-fold increase.
A five-fold increase over the operational B-2 force. And that provides flexibility, resilience, the sortie volume you need for a sustained conflict. It really transforms the bomber from that precious silver bullet asset into something more like a sustainable, persistent instrument of national power.
And it wasn't just buying them right. It was about keeping them flying.
Absolutely. This philosophy extends beyond just procurement. It includes a design for sustainment approach, addressing those long-term operational and maintenance costs. That was a direct, painful lesson learned from the B-2 experience.
Okay, so visually, both the B-2 and B-21 share that iconic flying wing silhouette. Which is inherently stealthy.
It is.
But I imagine the real story of stealth has evolved far beyond just the shape over the last few decades, hasn't it?
Oh, profoundly, yeah. While the flying wing is common, the advancements in low observable, or LO, technology over 30 years are truly significant.
So what defined the B-2's stealth?
The B-2 Spirit's design, it really represents the peak of analog-era stealth engineering. Its airframe is largely carbon fiber reinforced composites, no vertical surfaces to reflect radar energy back. It has that distinctive sawtooth trailing edge designed to scatter radar signals. 4 deeply buried General Electric engines. And those famous sugar scoop exhaust designed to cool and mask its infrared signature.
And the result, how stealthy was it?
The result was reportedly a radar cross-section, an RCS, smaller than a small bird. Really remarkable for its time.
And the B-21, it looks similar, but you can see refinements. What's the significance of those visible changes?
Absolutely. The B-21 Raider builds on that legacy, but with some remarkable refinements, as you say. It's visibly smaller and lighter.
How much smaller?
Well, its wingspan is around 132 to 140 feet, compared to the B-2's 172 feet.
Yeah.
And its max takeoff weight is roughly half, around 180,000 pounds versus over 330,000 for the B-2.
That's a big difference.
It is. And this isn't just a minor tweak. That reduction in size inherently contributes to a lower radar signature, and it allows for greater operational flexibility.
Yeah.
Basing, deployment, that sort of thing.
Okay. And the shaping?
Its shaping is simpler, cleaner. It lacks the B-2's complex sawtooth trailing edge. The engine inlets are more deeply blended into the fuselage, and it has these unique, seamless trapezoidal cockpit windows designed to eliminate radar-reflecting joints and edges.
Interesting. What about the back end, the exhausts?
Yes. Perhaps the most significant visual evolution is the engine exhaust design. It's a narrow, two-dimensional system embedded flush with the tail.
Flush?
Right, flush with the airframe, believed to be far more effective at reducing both infrared and radar signatures, especially from the critical rear aspect.
Which suggests?
It indicates a real focus on all-aspect, broadband stealth, meaning it's harder to detect from any direction, across a wider range of frequencies, not just head-on.
So it's not just the shape, then. It's what these planes are made of that really defines their stealth capabilities.
Precisely. That's the most critical and probably least visible leap. Material science. The B-2's low observable features, its LO coatings and materials, they were notoriously difficult and expensive to maintain.
I remember hearing stories.
Yeah, its first-gen radar-absorbent materials, the RAM, were delicate, susceptible to weather. Even just routine maintenance could damage them. They required frequent, really labor-intensive reapplication in specialized climate-controlled hangars.
Sounds like they needed a dedicated spa day for the B-2 after every flight.
You're not far off. No wonder it made the B-2 the most maintenance-intensive aircraft in the Air Force inventory. It was a major bottleneck for readiness and deployability.
So the B-21 addresses this head-on.
Head-on. In contrast, the B-21 uses a new generation of advanced materials and coatings. They're described as significantly more durable, resilient, and less costly to maintain, meaning they don't require the same level of specialized hangar care. That dramatically reduces downtime, increases sortie rates, and allows for wider deployment options.
Yeah.
It's about achieving operationally sustainable stealth.
Right.
That's a force multiplier for the entire fleet. Because, a stealth bomber that's stuck in a hangar isn't doing anyone any good.
No kidding. That's a huge shift, just from a practical standpoint. But moving beyond the physical airframe, the B-21 apparently represents a complete revolution in how an aircraft is even designed and built, thanks to its digital DNA.
Right. What's fascinating here is that shift. From the B-2 being sort of an analog masterpiece to the B-21 being fundamentally a digital aircraft. The B-2 Spirit was designed in the 1980s, apex of analog engineering for its time.
Used some computers, though.
It used early computer-aided design, CAD, yes, but it still relied heavily on physical mock-ups, lots of expensive wind tunnel testing, and that traditional design-build test cycle.
Which is slow and risky.
Inherently slow, expensive, and, risky for unforeseen complications down the line. The B-21's approach is radically different. It leverages a comprehensive digital ecosystem built on agile software, advanced manufacturing, digital engineering.
And at the heart of that is the digital twin.
Exactly. The core is the digital twin, a comprehensive physics-based virtual representation of the aircraft, maintained throughout its entire life cycle.
So how does having this digital twin translate into real-world benefits for such a complex machine? Does it really make that much of a difference?
So it's transformative. It drastically reduces risk and cost.
How?
By allowing engineers to test thousands of variables, resolve integration issues virtually before anything is physically built.
Can you quantify that?
Well, our sources do. Design changes during physical production for the B-21 were apparently just 1%. Compare that to 15–20% for typical clean sheet aircraft designs.
That's a massive efficiency gain.
Huge. It drastically accelerates development, collapsing that traditional design build test cycle. In fact, the very first B-21 test aircraft was what they call a production representative vehicle, meaning it bridged development and actual production right from the get-go. This whole digital design process, it's a strategic capability in itself. It dictates the pace of innovation for future aircraft.
Okay, that's about how they're built. But what about their actual brains, their central nervous systems? How do they think and connect?
That's another critical differentiator. You could say the B-2 was largely a self-contained platform,
Okay.
whereas the B-21 is designed from the ground up as a highly connected node in a much broader combat network.
So the B-2's systems were closed off.
Pretty much. The B-2 used highly advanced but proprietary avionics from the 1980s. State-of-the-art then, but its closed architecture made upgrades incredibly complex, time-consuming, and expensive.
Like adding new radars or weapons?
Exactly. Things like retrofitting AESA radar, integrating new munitions, or modern communication systems. It was a monumental task. The B-21, however, is born open.
Born open?
Yeah, open systems architecture was a core design principle. It uses standardized, non-proprietary interfaces.
So what does open systems architecture actually mean in practice for how the plane operates and evolves? How will it avoid those upgrade headaches the B-2 faced?
Well, think of it maybe like this. The B-2 was like a custom-built computer from the 80s. Only the original manufacturer could effectively upgrade its internal components, and it was costly.
Got it.
The B-21, on the other hand, is more like a modern PC with standardized ports and software interfaces, USB, Ethernet, that kind of thing, but for military systems.
So plug and play, almost.
In a highly sophisticated way, yes. It future-proofs the aircraft, allows for competitive sourcing of new tech, rapid, cost-effective integration of new sensors, communications, electronic warfare systems from various vendors, not just one.
And that enables its network role.
Absolutely. This open architecture enables its role as the, quote, backbone of the future for U.S. air power and part of a family of systems. It's designed for advanced data fusion, sensor integration, weapon integration, layered networking, even cloud-based environments eventually.
So it changes the bomber's job description.
Fundamentally, the B-21 isn't just a bomber anymore. It's conceived as a survivable penetrating sensor, intelligence-gathering platform, and commanding control node.
Wow. Controlling other aircraft?
There's even speculation, quite strong speculation. It could direct swarms of unmanned collaborative combat aircraft, CCAs, basically drones acting as loyal wingmen.
Interesting. And the payload size reflects this. It's smaller than the B-2s.
It is, about 20,000 pounds compared to the B-2s, over 40,000 pounds. And that likely reflects internal volume being dedicated to these advanced avionics, sensors, and networking capabilities for these new roles.
So it's a shift from just being a platform to being a node.
Exactly. Acting as the quarterback of the deep strike mission, as some have put it.
Okay, this next point might be the most revolutionary feature, actually. The role of the human crew.
Yeah, this evolution, it fundamentally alters the calculus of risk, especially for the most dangerous missions.
How so?
Well, the B-2 Spirit operates with a two-person crew, a pilot, and a mission commander. Its whole operational concept is built around their capabilities and their limitations.
Those incredibly long flights.
Famously long missions, yeah. Often over 30 hours, nonstop. It really represents the absolute apex of what a man-penetrating bomber can achieve.
And the B-21 takes a truly different path, going beyond just manned operations.
Exactly. It introduces what you could call a monumental technological and doctrinal leap. The B-21 is designed to be optionally manned.
Optionally manned, meaning?
Meaning it can perform missions entirely autonomously, without a crew on board. That implies incredibly advanced AI and system reliability.
Okay, what are the strategic implications of that? That sounds huge.
Immense. Think about it. The greatest limiting factor for sending these high-value stealth bombers into a peer conflict. It's the risk to the invaluable human crew.
Right. Losing the people is worse than losing the plane.
Far worse. The prospect of losing a crew can lead to what some call strategic paralysis, where commanders might hesitate, understandably, to send a bomber into the most lethal zones.
But the B-21 changes that equation.
It changes the calculation entirely. For those really dangerous missions deep into mature A2AD networks, the aircraft can be sent unmanned. The financial and operational blow of losing just the aircraft, while significant, is far more acceptable than losing its crew.
So it makes the threat more credible.
Absolutely. It restores profound credibility to both the air-breathing leg of the nuclear triad and conventional deep strike capabilities. It sends a message. No target can ever be considered a true sanctuary.
We've talked about its design, its evolved stealth, its digital brains, even its optional crews. But ultimately, in a long conflict, it's about whether you can keep these incredible machines flying. Sustainment.
Exactly. And what's fascinating here is how the B-21 really demonstrates a profound shift towards the long-term economics of air power.
Sure.
The B-2, while a technological marvel, was defined by an extraordinary maintenance burden.
The Hangar Queen problem.
You could say that. It's widely regarded as the most maintenance-intensive aircraft in the Air Force inventory. Those delicate alloy coatings, they degrade from weather, routine wear,
Right.
requiring meticulous, time-consuming, and very costly reapplication in those specialized climate-controlled hangars we mentioned.
Which limits where they can operate from.
Exactly. It limits operating bases and severely constrains sortie generation rates. It was just a persistent drain on resources.
So it sounds like the B-21 was designed with maintainability really baked in from day one, not as an afterthought.
That's the paradigm shift. Sustainment was a critical performance requirement from the earliest design stages for the B-21.
And how does it achieve that better sustainment?
Through several key technologies we've touched on. First, that revolution in material science.
The more durable coatings.
Right. Far more durable, resilient RAM and coatings. They mean less degradation, dramatically reducing low maintenance needs, lower operational costs, faster turnaround times, higher fleet readiness.
Okay, what else?
Second, the digital twin again. It's a powerful tool for life cycle sustainment. Sensors on the actual aircraft constantly feed data back to the virtual model. This allows it to anticipate failures, enabling predictive maintenance. It also helps with efficient logistics, even providing augmented reality support for technicians working on the plane.
Wow. And third?
Third, the native open systems architecture. It makes physical repairs and upgrades simpler and more affordable. You can use competitive sourcing for components, ensuring long-term supply chain health. You're not locked into one supplier for everything.
So the cumulative effect is?
The cumulative effect is a bomber designed for much higher sortie rates, increased availability, and significantly lower operational and sustainment costs over its lifetime.
Makes sense.
This logistical superiority, you could argue, is in itself a strategic weapon. It allows for prevalence and a potential war of attrition and logistics. It provides a more credible, more enduring deterrent force.
So, putting it all together, what does this evolution mean for the future of air power?
Well, to summarize, I think the key takeaway is the B-21 Raider isn't just an upgrade. It's a fundamental shift in doctrine. It balances that exquisite capability we saw in the B-2 with, finally, economic reality.
Right.
And we've seen this built upon, what, maybe 5 core pillars?
All right, well, let's recap them.
1, sustainable stealth, durable, operationally viable materials. 2, digital engineering leveraging that digital twin for de-risked accelerated development. 3, native open architecture, future-proofing it for rapid, affordable upgrades and network-centric operation.
Got it.
4, optional manning, fundamentally altering the risk calculus for those deep penetration missions. And 5, designed in affordability, enabling a larger, more resilient and strategically potent fleet.
So it really shifts the focus.
It really shifts the focus from platform-centric thinking, how good is this one plane, to network-centric warfare. How does this asset contribute to the overall combat network?
It truly sounds like the physical embodiment of a new American doctrine for strategic power, forged from those hard-learned, expensive lessons of the B-2 Spirit.
It does. And maybe this raises an important question for you, the listener, to consider. As the B-21 redefines what a bomber is, how might this blend of advanced autonomy, this deep interconnectedness, how might it fundamentally reshape our whole understanding of what it even means to be prepared for conflict in the decades to come?